Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We have been discussing the solutions of the problems that appeared in the CSIR National Eligibility Test held on February 28, 2025. Today, we discuss the solution of a problem from the section Complex Analysis, and the question is related to the concepts of entire functions. This question is placed in part C, which is a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 704162. This question is suitable for all these examinations. Right. The given question is, let f be an entire function. Let f be a function from C to C, and it is given to be an entire function such that f of z is equal to f of iz for all z belongs to C. Which of the following statements are true? We are given four options. Option 1. F of z is equal to f of minus z for all z belongs to C, and f prime 0 is equal to f double prime 0 is equal to f triple prime at 0 is equal to 0. Option 3. There exists an entire function g from C to C such that f of z is equal to g of z to the power of 4 for all z belongs to C. Option 4. F is necessarily a constant function. Right. Let's now discuss the solution of the problem in detail. We have f from C to f is a function from C to C, and it is given to be an entire function, and it is satisfying f of z is equal to f of iz for all z belongs to C. Since f is an entire function, it has a power series expansion about the origin, and that is f of z is equal to sigma n is equal to 0 to infinity a n z power n. Now, f of z is equal to f of iz for all z belongs to C. This is given. So, in this power series expansion, you substitute f of z is sigma n is equal to 0 to infinity a n z to the power of n is equal to f of iz. In this power series expansion, wherever there is z, substitute iz. So, that is sigma n is equal to 0 to infinity a n iz to the power of n. And iz whole to the power of n will be I power n into z power n. That will be equal to sigma n is equal to 0 to infinity I power n a n z power n. Now, equating the corresponding terms from these two power series, we will get a n is equal to I power n into a n for all n belongs to the set of natural numbers union the singleton set 0. That is n for all n for all non-negative integers n. And this will imply I power n is equal to 1. When I power n is 1, and you can see I power 4 is 1, I power 8 is 1, so on and so forth. And this will imply n is equal to 4m for all m belongs to n union singleton 0. Right. Now what happens for A1, A2, A3, so on and so forth? So now you see A1 is equal to an is equal to I power n an. So n is equal to 1. A1 is equal to I into A1. This is true only when A1 is equal to 0. Now A2 is equal to I square A2. I square is minus 1. So A2 is equal to minus A2 will imply 2A2 is equal to 0. A2 is equal to 0. In a similar fashion, A3 is equal to I cube A3, this is not A2, A3, and that will be equal to A3 is equal to minus I A3. This is true only when A3 is equal to 0. And if you see A4 is equal to I power 4 A4, I power 4 is 1, A4 is equal to A4, which we have already told you that in general, seeing this pattern, A suffix 4m plus 1 is equal to A 4m plus 2 is equal to A 4m plus 3 is equal to 0 for all m belongs to n union the singleton 0. And what happens? What happens? You take fz, right? Take its power series expansion. In that A1, A2, A3 will become 0, and it will start from A4 onwards. And by the by, A0 also, A0 is equal to A0 is equal to I power 0 A0. So A0 is equal to A0. So A0 will remain. So the summation starts from m is equal to 0 to infinity A 4m. We already told you n is equal to 4m into z to the power of 4m. And expanding, you will get A0 plus A4z to the power of 4 plus A8z to the power of 8 plus so on and so forth. And this is equal to sigma m is equal to 0 to infinity. I can write this as Bm z power 4m, where Bm is A4m, where m runs from 0 to infinity. Right. So that means this is again a power series expansion. So this is equal to some function g of z to the power of 4. Z to the power of 4. So clearly g of z to the power of 4 is a power series expansion. Therefore it's said analytic everywhere. Therefore it's an entire function. So g of z to the power of 4 is an entire function. Thus there is an entire function g from C to C such that f of z is equal to g of z to the power of 4 for all z belongs to C. Let's look at the option 3 here. The option 3 precisely says there is an entire function g from C to C such that f of z is equal to g of z to the power of 4 for all z belongs to C. Thus the option 3 is true. We continue the discussion in the next slide. Right. We call on option 1, f of z is equal to f of minus z for all z belongs to C. What is fz? Fz is equal to g of z to the power of 4. G of z to the power of 4. So clearly it's an even function. So if you replace z by minus z, you will get f of minus z is equal to g of minus z whole to the power of 4, that is z to the power of 4, that is g of z to the power of 4, that is once again f of z. So we get f of minus z is equal to f of z. We have f of z is equal to g of z to the power of 4 for all z belongs to C. Clearly it is an even function. Therefore f of z is equal to f of minus z for all z belongs to C, and thus the option 1 is true. Option 2, f prime 0 is equal to f double prime 0 at 0, f triple prime at 0 is equal to 0. Yes, it's easy. You take f of z, differentiate once, twice, thrice. So f of z is equal to g of z to the power of 4 and differentiate once, you will get 4z cube z prime z, differentiate twice, 12z square, because 4z cube, its derivative is 12z square, g double prime z, and the third derivative is 24z g triple prime z. So substitute z is equal to 0, you will get f prime 0 is 0, f double prime 0 is 0, f triple prime 0 is 0. Thus, the option 2 is also true. We move on to the last option, option 4. F is necessarily a constant function. No, it can't be a constant function. It is not a constant function. F of z is a power series expansion is there. So how can it be a constant function? So take a counter example. F of z is equal to z to the power of 4. And f of iz is equal to iz to the power of 4, that is equal to z to the power of 4 is equal to f of z. So that means it satisfies the condition f of z is equal to f of iz for all z belongs to C. But this is not a constant function. It is not a constant, but it is not a constant function. F of z is equal to z to the power of 4 is not a constant function. Therefore, the assertion that is given in option 4 is not true. So option 4 is not true. Summarizing all the options, the answer to this question is options 1, 2 and 3. That is the detailed discussion of the solution of this problem, and it is definitely a simple and straightforward question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will definitely meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.